Welcome student, welcome to my channel. Now here I am going to discuss some important question relevant to JEE, NET, WBGE, CUET, etc. So the first question is the correct statement about ICL5 and ICL4 minus. So this is the question from chemical bonding. So ICL5, how can we determine the hybridization? So iodine valence electron of the iodine is 7 plus 5 chlorine atom divided by 2, that is 6. 6 means sp3d2. sp3d2, that is octahedral geometry. Octahedral. If we draw the structure, so this is the octahedral. Iodine is in centrals of the octahedron, and 5 Cl are at the corner. One is here and one lone pair is present around this octahedron. So this is the structure of ICL5 and this is octahedral, but its shape is square pyramid, square pyramidal or square pyramid, due to the presence of one lone pair electron. So the correct statement about ICL5 is square pyramidal. Okay, ICL5 is square pyramidal. So the option B or C can the answer. Now here, if we observe the structure of ICL4 minus, here we can also determine in this way: 7 the valence electron of the iodine, 4 Cl plus 1 for 1 negative charge by 2. So this is also 6, that means sp3d2. This is also octahedral geometry. If we draw the structure of this compound I and 4 Cl minus 4 Cl, actually 4 Cl atoms are in this side and 2 lone pair are present around central atom iodine, and the overall charge is minus. So it has 2 lone pairs. It has 2 lone pairs present in ICL4 minus, but the shape of this molecule is square planar. Square planar. Okay, square planar geometry. So the correct answer will be option B, that is ICL5 is square pyramidal and ICL4 minus is square planar. So correct answer will be option B. Option B will be the right answer. Okay. Next question. The question is about the diamagnetic and the bond length. So this question can be explained by the help of MO diagram or MO theory, molecular orbital theory. Okay. So here in the compound C2 2 minus, the number of electron is 6 plus 6 for 2 carbon and plus 2 for 2 negative charge. So overall 14 electron, and it is isoelectronic with nitrogen N2, and as we know that N2 is triple bonded. Okay. Similarly for N2 2 minus, the number of electrons 7 plus 7 plus 2 is equal to 16 electron, and for O2 2 minus, 8 plus 8 plus 2, that is 18 electron, and for O2 this is 8 plus 8 that means 16 electron. So which one is diamagnetic and has the shortest bond length? As we know that O2 is paramagnetic. O2 is paramagnetic because if we see the MO diagram or MO energy level, here we can write sigma 1s star, sigma 2s star, sigma 2pz, pi 2px is equal to pi 2py, and pi 2px star is equal to pi 2py star, and sigma 2pz star, and sigma 2pz star. So this is the energy order for the electron above 16 electron. So for O2, if we arrange the electron like this, 2, or we can write above, so 2 to 4 to 6 to 8 to 10, 11, 12, 13, 14, 15, 16. So in this case, here we can see that 2 unpaired electrons are present. 2 unpaired electron present in pi 2px and pi 2p star. So it is paramagnetic. That's why it is paramagnetic. Okay. So O2 is para. Okay. For O2 2 minus, now the extra 2 electrons are coming in this orbital. If we change the color, extra 2 electrons are present in this orbital also. So both are paired up. Now it becomes paired up electron. That's why it is diamagnetic. It is diamagnetic. Okay. For N2 and C2, the energy level order will be like this: sigma 1s star, sigma 2s star, pi 2px is equal to pi 2py, then sigma 2pz, then pi 2px is equal to pi 2py star, and then sigma 2pz star. Okay, so if we arranged electron for N2 2 minus, that is 16 electron, so the electron can be arranged like this: 2 to 4 to 6 to 8, 9, 10, 11, 12, 13, 14, 15, 16 for N2 2 minus. Okay, 16 electrons. So here we can also see that these are unpaired electron. These are unpaired electron. That's why it is also paramagnetic. Okay, this is also paramagnetic. Similarly, for C2, 14 electrons can be arranged like this. There are 14 electrons. So 2 to 4, 6, 8, 9, 10, 11, 12, 13 and 14. That means paired up electron. That's why it is diamagnetic. So it is diamagnetic. It is diamagnetic. C2 is diamagnetic. Now the question is, which one is diamagnetic and has the shortest bond length? So among the 4 compound, here you can see that O2 is diamagnetic. Yes, it is diamagnetic. O2 is para. O2 is para. C2 is diamagnetic, and N2 is para. So O2 and C2 are diamagnetic, but and has a shortest bond length. And shortest bond length, how can we determine the shortest bond length? If we determine the bond order, so bond order can be calculated like this. Bond order BO is equal to bonding electron minus anti-bonding electron by 2. So for C2 minus, the number of bonding electrons are 2 to 4 to 6 to 8 to 10 minus anti-bonding electrons are 2 to 4 by 2, that is 6. That means 3 bond order. Okay, there are 3 bond order between C2 but in case of O2 the bond order will be 1. Okay, for O2 the bond order will be 1. Here we can also write bond order for O2 which is diamagnetic. So number of bonding electrons in O2 2 to 4 to 6 to 8 to 10. That means 10 minus number of antibonding electron 2 to 4 to 6 to 8. That means 10 minus 8 by 2 is equal to 1. So bond length 1 bond order. That means it has higher bond length. But the question is asked about shortest bond length. So shortest bond length will be 1 which has higher bond order. As we know that bond order is inversely proportional to 1 by bond length. That's why the correct answer will be option B, that is C2 which is diamagnetic as well as shortest bond length. Diamagnetic as well as shortest bond length, because it has triple bond. Okay. Next question: which one of the following alkenes when treated with HCl yields majorly an anti-Marconi product? So as we know that if we take in a compound propene CH3 CH double bond CH2, and if we add simple HBr, then we will get CH3 CH, here Br, and here CH3, and it is CH3. This is simply Marconi product. But if we add HBr in presence of H2O2 or any peroxide, then we will get CH3 CH2 CH2Br. Okay, this is simple Marconi product, and this is simple anti-Marconi product. Anti-Marconi. Okay, so HBr has an peroxide effect, but when you treated with HCl, it has no peroxide effect, but among the given compound, the one which shows anti-Marconi effect, which is option B. Option B, because in case of option B, here we can write the 3-fluorine has minus I effect. That's why if we add HCl, then if H plus can abstract by the CH2 group, the structure will be here we can write the structure will be CH plus CH3, and here 3 fluorine atoms are present. But if this carbon is attached with hydrogen and carbocation is formed in this side, this is 1 degree and this is 2 degree, this is 2 degree. So according to the stability concept, 2 degree is more stable than 1 degree, but here we can see that the 3 fluorine atoms, due to the presence of 3 fluorine atoms which has minus I effect, this carbocation is very unstable, very much unstable. This is unstable, actually this is unstable carbocation. In comparison to that, this is stable, and Cl minus can attack this CH2 and we will get the anti-Marconi product CH2 Cl without any presence of H2O2. Okay, without presence of H2O2. That's why the correct answer will be option B. Option B, because CF3 CH CH2 gives an anti-Marconi product, and this is anti-Marconi product also. Anti-Marconi product. Okay. The next question: the major product obtained in the following reaction is. So in this question, there is a given of one amine, and it is 1 degree amine, and the reagent is chloroform KOH. The first step is chloroform KOH. That means it is a carbylamine reaction. Carbylamine reaction. Okay. So in carbylamine reaction, what happened? RNH2 in presence of chloroform KOH, the product is RNC, isocyanide is formed. So in the first step, this NH2 is converted to N triple bond C. No change of this group, CN. Okay, and the next step is PDCH2. That means it is a reduction process. This is nothing but reduction. So in this reduction process, what will happen? These groups are reduced. So NH is converted to secondary amine. That means NHCH3, and this CN is converted to CH2 NH2. Okay, and what will happen? For this C double bond O is converted to OH. secondary alcohol. So according to this, the correct answer will be option D. So option D will be the correct answer, because here NaCH3 is formed, COH is formed, and CH2NH2 converted, CN is converted to CH2NH2. Okay, the right answer will be D. And the last question, the ion that has sp3d2 hybridization for the central atom is. So for IF6 minus, the iodine central atom, so valence electron of the iodine is 7 plus 6 fluorine plus 1 negative charge divided by 2, that means 7, that is sp3d3 hybridization. Okay, for ICl4 minus, the valence electron of iodine is 7 plus 4 plus 1 by 2, that means 6. So the hybridization is sp3d2, and this is the correct answer. Okay, this is the correct answer. If you also determine the hybridization of ICl2 minus also, so central atom 7 plus 2 fluorine plus 1 charge by 2, that is 5, that means sp3d. And for BRF2 minus, the valence electron of bromine 7 plus 2 fluorine plus 1 charge by 2, that means 5. So this is also sp3d. So it is TBP structure, it is TBP. This is also TBP structure. Structure is TBP, but shape must be different due to the presence of lone pair. This is octahedral, and this is PBP, pentagonal bipyramidal, sp3d3. So the correct answer will be option B, ICl4 minus, which has sp3d2 hybridization of the central atom iodine. Okay, thank you for listening. If you like the video, then share with your friends and stay tuned for the upcoming videos. Thank you.